As we all know, multi-tenancy in Kubernetes has always been a balancing act between efficiency, security, and giving teams enough autonomy. Now, vCluster Labs is taking a big step forward with private nodes, a feature designed to unlock stronger isolation and new kinds of workloads inside Kubernetes. And joining me today for the brand new episode of Kubestruck is Lukas Gentele, founder and CEO of vCluster Labs, to talk about what this release means, how it works under the hood, and why it could change the way teams run sensitive or resource-heavy applications on Kubernetes. Lukas, it's great to have you on the show.
Yeah, great to be on TFIR again, Swapnil.
Well, the most exciting thing is that you folks changed the name of the company. So let's talk about the name change. What drove it?
Yeah, I mean, vCluster is really the project and product that, everybody knows us for. And I think it was unnecessary confusion to have Loft Labs, vCluster as a project, right? So vCluster Labs as a company name, streamlines things, makes it a lot easier for folks. And I think probably makes it easier also for, new candidates when they look at a job description, for example, right? They may know vCluster, they may not know Loft Labs actually. It's also when we go to a KubeCon or any other conference, our booth usually is orange. It talks about vCluster predominantly, right? But then, people, you're in conversations and people ask, oh, what do you do? I work for Loft Labs. And people don't always connect the dots right away. vCluster Labs is going to make this a lot easier going forward. It's all consistent, all focused on vCluster.
That's so true, because whenever we go to events like KubeCon, that's what we see. vCluster. So this name change is apt. Now, if you look at the origin of Loft Lab from early days, one of the problems that you folks have been talking about and working on solving is Kubernetes multi-tenancy. What are some of the big pain points you still see out there when it's come to multi-tenancy?
Yeah, multi-tenancy is still a big topic. I think with the advent of AI and people bringing in GPUs into their data center, I think the big question really is, how do you do multi-tenancy on a large supercomputer effectively? And that is a very challenging question. And since more and more workloads shift over, maybe from traditional Slurm clusters to more of the Kubernetes cloud native world, that question is a really big one. Tenancy in general in Kubernetes, whether, sometimes single tenancy is the right decision, but how do you run, single tenant clusters effectively is also a big challenge. And I think that whole tenancy concept from, completely separate single tenant clusters over hard multi-tenancy all the way to soft multi-tenancy in pre-production and development, I think most companies are going to have on the spectrum, they're going to have use cases, pretty much across the entire spectrum. And it is really, a big question of what tool do you pick for each of these use cases. And we're trying to, as vCluster, we're trying to be a solution for variety and ideally the entire spectrum. So you can, have a single tool that can serve multiple use cases with different degrees of isolation needs that you may have, right? In production, you need stricter isolation, maybe hard multi-tenancy, maybe even single tenancy. In pre-production development, CI for your ephemeral clusters, maybe soft multi-tenancy is a viable approach. Maybe namespaces are even viable for certain scenarios. And we want to be, as lightweight as a namespace in one configuration, as hard isolated in another configuration, and even in single tenant, applications, we want to be, a suitable solution for you.
And how is your approach different from others, the way you solve these challenges, which also reflect on the kind of adoption you're seeing of vCluster?
Yeah, I think we really started as a solution that you can adopt really, really quickly. So we started at the, soft multi-tenant side of the spectrum. It's really easy to set us up. You don't even need things like, cluster API, for example, or any kind of central controller, which is the Helm chart, right? Like to deploy a vCluster, you run Helm install, you run kubectl apply. Anybody who can create a stateful set of deployment and a service in a Kubernetes cluster can spin up a vCluster. That means if you just have an individual namespace, right, and your company does namespace as a service internally, you can deploy a vCluster and effectively it feels like you have your own cluster now. I think that's beautiful in terms of, adoption and getting started, making it as easy as possible for, a wide set of users to just get their hands dirty with vCluster. But then, as you dig deeper into the vCluster YAML and the different configuration options we have, it gets a lot more advanced. You can configure vCluster, in a much more hard multi-tenant and secure and isolated way. Then we, launched vNode earlier this year to, run on the node and create these virtual nodes for stricter isolation. And most recently, we announced private nodes, which effectively allows you to join nodes directly into the vCluster control plane, effectively creating single-tenant clusters, so completely isolated, completely separate CNI, completely separate CSI for each one of your clusters. And, that covers the entire spectrum. I think the attention we're getting in the CNCF ecosystem and the broader, tech community right now is really because we're really easy to adopt and really easy to try out. But then we also serve, some of the most difficult use cases when it becomes, critical to isolate workloads in production scenarios.
You and I have talked a lot about the tenancy spectrum. Where do private nodes fit on that spectrum, and what new use cases does this unlock?
Yeah, private nodes is very, very interesting. It kind of turns vCluster into something different than it was for years. Because so far in people's heads, vCluster is a cluster in a cluster. And the vCluster uses the nodes of the underlying cluster. To some extent, we're creating somewhat of a hybrid now. So you still have the control planes, the vCluster control planes, the vCluster pods. They still run on top of a Kubernetes cluster. So there's a host cluster already existing. It can be pretty much any cluster that's like, OpenShift or Rancher, or just a vanilla bare metal, Kubernetes cluster. Whatever Kubernetes distro you're using, you can spin up vCluster control planes on top of that. The traditional shared node or dedicated node vCluster would use the nodes from the underlying host cluster now. But with private nodes, you get a different option. What you can do is you can take a VM, or you can do, a bare metal machine, and you can join it directly into the vCluster. So only this vCluster has this node. This node is not part of any other Kubernetes cluster. It's not part of the host cluster. No other vCluster, no host cluster. Nothing can reach it. That node is completely private to this particular vCluster. It's essentially under the hood, if you imagine like kubeadm join, right? The command you would run to join a regular node into a regular traditional Kubernetes cluster. We use something similar, and we're kind of building on top of this in vCluster, but we're making it even easier. We're streamlining a lot of things. We're automating a lot of things for you. So it's a single command you run on any VM or any bare metal machine to join it, as a private node into your vCluster. And that effectively gives you a completely single tenant cluster. But your control planes, they still run on top of a shared cluster. So you have this control plane cluster that could host, clusters that, sync pods and use the nodes of the underlying cluster. But then you have other, vClusters, which actually have private nodes for more isolation and stricter separation of these workloads.
You folks are making big announcements. So talk about what you folks are announcing.
Yeah, so vCluster private nodes is really just a starting point. The other exciting announcement we're making is vCluster auto nodes. Auto nodes is our take on a managed solution for Karpenter. Obviously AWS started the Karpenter open source project. It's an amazing open source project. It allows you to, give it different types of, virtual machines, for example, EC2 instances in AWS, Azure VMs, right? If you're in AKS. And, these cloud providers have baked Karpenter into their offerings, and they allow you to, get the right sized VMs for your workloads. So let's say you have, some big workloads and a bunch of small workloads, right? Karpenter would make the most cost-effective decision on how to bin peg things on different nodes. It would say, oh, give me one of these nodes and two of these smaller nodes and then one extra large node here. And I want to join all these nodes in my cluster because that maximizes utilization and reduces cost overall. That's really what Karpenter does really well in the public cloud. So now what we're doing is we're baking Karpenter directly into vCluster. So it comes batteries loaded, it's super easy to configure. and it works in any environment. And that's the novelty here. Because Karpenter so far has been adopted in EKS predominantly, since obviously EKS or the AWS team open sourced Karpenter, and AKS has also integrated Karpenter into their managed Kubernetes offering. But we're bringing Karpenter pretty much in any environment, including the private cloud, including bare metal. And I think that's really exciting. So wherever vCluster runs, whether that's the public cloud or the private cloud or bare metal, you can give it the connection to any kind of nodes or node types that are available, and it will automatically mount the right private nodes into your virtual cluster to create the most efficient Kubernetes cluster possible. So far, we are building essentially on a couple of different what we call node providers. The first one is Terraform. Terraform is, by extension, OpenTofu. We're supporting both flavors here. So whether you run Terraform Enterprise or you're running, open source, OpenTofu, both works with us. We are just using the HCL definition here effectively. And you can provision any node that you can provision with Terraform, which is great because there are Terraform providers, obviously, for all the major public clouds, even for niche cloud providers, right? Tier 2, Tier 3 cloud providers. There's always a Terraform provider for any of these public cloud environments. But even in the private cloud, right, there is Terraform providers for OpenStack, for example, for Metal as a Service from Ubuntu, from Canonical, right? So pretty much all of these environments can be covered. And with private nodes and auto nodes, you can now join them directly into your vCluster. And it also can configure the networks like VPCs, VPNs, right? Pretty much anything you can define in Terraform, you can also spin up as part of auto nodes. Besides the Terraform OpenTofu provider, we also added quick starts for the major public clouds. So if you just want to have a setup in, AWS, Google Cloud, or Azure, it really takes a click. We automatically set up things for you. And then you can fork our, Terraform quick start repositories and customize them to your needs, but we'll give you a resilient starting point that's really, really easy for any of the major public clouds to get that true auto scaling experience with Karpenter out of the box with vCluster. The other exciting thing we integrated is KubeVirt. So if you're in the private cloud and you have a set of bare metal machines, sometimes it's great to just take a bare metal machine and join that into your vCluster as a private node. And, AutoNodes does it automatically. But sometimes your workloads aren't always that big. Your clusters are relatively small. So a slice of a bare metal machine may be sufficient for you. So we integrated KubeVirt so that we can automatically with KubeVirt create virtual machines on top of your bare metal machines with KVM. And then we effectively get you a slice of that bare metal machine as a virtual machine, join that into your vCluster as a private node. And last but not least, we also integrated NVIDIA's BCM, which is essentially the node provider in NVIDIA's flagship product, the SuperPod and BasePod, etc. Right? So if you're running DGX systems by NVIDIA, you're most likely going to operate BCM, which is the tool that equips the nodes with the operating system, right? DGX OS. It PXE boots these nodes. And since we directly integrate with BCM, we can also spin up these nodes. We can configure the network. There's a bunch of network providers that we're starting to integrate with. And last but not least, since, that Terraform provider concept is available, you could technically write your own Terraform or OpenTofu provider and customize it completely to your needs. So what we ship with our, Karpenter auto nodes integration here is really something incredibly flexible. And it works not just in the public cloud, it works in the private cloud and even in hybrid scenarios. So you could, for example, say, I have this set of DGX nodes with GPUs, and then I have these bare metal CPU nodes. And additionally, I want overcapacity from AWS EC2 instances. You can give all of this to AutoNodes, and AutoNodes will configure the most effective cluster for you, right? The most cost-effective cluster. So it will essentially say, okay, GPU nodes go on my DGX systems, But if there's no capacity available, I can take EC2 instances to a certain degree and get GPUs from AWS to augment, what's available in my private cloud. And then on the CPU nodes, it could say, I'm going to take a bare metal CPU node, joining it in for a very large workload. And then for a very small workload, I'm carving out a slice of a bare metal machine with KubeVirt launcher VM on there. So it's an incredibly flexible system. It's super, super powerful. We really want the most optimized Kubernetes cluster possible in any environment, even across different environments. And we even wire up the networking. We essentially spin up a VPN automatically between the nodes in different environments so they can securely communicate with each other. It's an incredibly powerful technology. Encourage everybody to take a look at it.
Now let's also talk about what role does vCluster control plane play in making this setup possible?
Yeah, the vCluster control plane from day one was a control plane running inside a container, right? So if you spin up a vCluster, you kind of need a cluster to start with in order to run your first vCluster. So we assume you already have some kind of Kubernetes cluster, whether that's Minikube or Docker Desktop on your local machine or an EKS cluster, an OpenShift cluster, whatever environment you have. We kind of assume you have a Kubernetes cluster. You can spin up a pod that now runs a vCluster control plane. However, some of our customers have also asked for, can't you run a full-blown cluster without any prerequisites, right? Can you run directly on this set of VMs, right? Just like, K3s, RKE2, OpenShift, right? You can just launch them directly on a set of bare metal machines or VMs. And that's actually the exciting announcement that we're planning for October. So October 1st, we are announcing vCluster standalone, and that will essentially provide the answer to this question that came up a bunch of times in our customer base.
I also noticed that the syncer gets disabled in this model. Why is that important, and what does it mean for users?
So the syncer has been an essential part of vCluster from day one. It effectively syncs pods from the vCluster's context down to what we call the host cluster, that underlying cluster where the vCluster control plane runs inside of. And so far, when you want to reuse nodes from the underlying cluster, that's a great approach. However, if you're using private nodes, you now have nodes directly available to the vCluster. So pods don't need to be synced to the host cluster in order to be scheduled by the scheduler of that host cluster. Instead, if you only have private nodes in this vCluster, you can turn off the syncer entirely. And then you can have the vCluster just run a regular Kubernetes scheduler or any kind of specialized scheduler, right? So if you're in AI land and you're scheduling, inference or training workloads, right? You might have Run AI's highly efficient scheduler, or you run things like Volcano, for example, in the open source space. And then effectively your vCluster scheduler or any of these specialized schedulers can directly schedule pods on the private nodes. So no syncing is required when you're using vCluster with private nodes, and by extension, vCluster with auto nodes as well.
From a team perspective, how seamless is node joining process? Do tenants feel like they are just working with standard Kubernetes or something else?
It's very important to us to be as close to vanilla Kubernetes as possible. We don't want to meddle, with the distro. I think there was a time and place in the Kubernetes ecosystem where every Kubernetes vendor wanted to push their own distro and their own take on Kubernetes, and they bolted on a bunch of things and redefined a bunch of things, right? We don't think that's necessary anymore these days. Staying as close to vanilla Kubernetes as possible offers obviously the benefit of, less lock-in. Customers don't necessarily want to choose a distribution that locks them in, that is something different than upstream Kubernetes. What we're doing is, instead of, redesigning a new distro for Kubernetes, we are repackaging vanilla Kubernetes. So one of the things we do is, and it's a nightly build, we essentially take the Kubernetes binaries, the regular Kubernetes binaries, and we join them together into a single container image. And then inside that image, we run a process supervisor to essentially launch the control plane components of vanilla Kubernetes. And that means we package Kubernetes differently, But if you were to run, Kubernetes just like, kind or things like that, right? Completely on your own, you could run the upstream vanilla distro rather than, running our packaged version. But the beauty is we just take the upstream binaries directly from the latest releases. So if there's a vulnerability in Kubernetes and they do a patch release today, you're going to get an updated version of our Kubernetes tomorrow. Maybe even today, if we hit a button in the CI pipeline and trigger it earlier than the nightly build, right? But it's really, really quickly for us to produce and stay as close to the release cycle of regular Kubernetes. And I think that is very important to customers.
Let's get into workloads. Why is this model especially well suited for, of course, these days, the hottest topic is AI ML, GPU heavy workloads, and workloads that involve sensitive data?
Yeah, I think effectively Kubernetes itself is making a big push towards supporting AI and specialized workloads better than it did before. I think initially in the scope of Kubernetes, it was very, very heavily centered around long-running, web server type applications. And with the recent advancements in Kubernetes, like DRA, for example, right, dynamic resource allocation, big push has been made towards how can we request certain specific hardware, right? Because when you're saying I need, 3 GPUs to run this, well, it really matters if this is a commodity GPU or if this is a newest like Blackwell series from NVIDIA type GPU, right? And I think Kubernetes itself has been making huge advancements to support these kind of distinctions much, much better than in the past. So any innovation that comes out of Kubernetes core is obviously immediately available to vCluster users. And on top of that, with things like auto nodes that we're just launching and starting to tell the world about, we're obviously helping companies to right size their GPU tenant clusters, because one of the biggest challenges is, let's say, as you mentioned, for privacy reasons and for the sensitivity of certain like PII data and other very, very sensitive business critical data, you want to keep, your AI inference workloads running in your private data centers. Maybe you even build a custom data center because, electricity needs and all kinds of things are different for GPU workloads. So maybe you have this large contract with Oracle to build a new AI data center for you. I think there's been a bunch of news recently around these large data centers being commissioned, obviously for the biggest companies in the world. But I assume there's also going to be, pushes from smaller enterprises and traditional, like banks and insurance companies that want to also participate in this, race towards AI efficiency. And if they're running GPUs on their own, the question really is, okay, you have 1,000 GPUs now. How do you split it up across, your 10 business units or your 5 ML teams, right? How do you do that? So one of the, great things about vCluster auto nodes is you don't have to statically assign, this GPU belongs to this tenant, this GPU belongs to this tenant. Instead, you have a pool of GPUs and GPUs like DGX servers, for example, and then auto nodes with the Karpenter integration automatically assigns on demand these GPUs to the right tenants. And maybe that allocation is going to change tomorrow because one of the teams runs a large, fine-tuning workload this week, but next week they're pretty much done with this, and they can return some of these GPUs back to the pool for others to use in the organization. So I think fair use across teams and across departments is a major concern for a lot of enterprises when they embark on the private cloud GPU journey.
And since we are talking about a lot of flexibility and freedom with private nodes, can teams bring in their own networking, storage, or GPU drivers?
Yeah, absolutely. We even integrate with some of the specialized networking providers out there. There's an announcement that I'm very excited about, specifically in terms of a partnership in the making. I can't talk about it publicly yet, but it'll be available in a month or two, and it'd be pretty exciting.
How can existing vCluster customers take advantage of private nodes? Do they need to make big changes to get started, or they can seamlessly continue to work as they have been working?
Yeah, that's one of the great things. So vCluster YAML as our canonical, configuration file. There's an option in there, private nodes. You can enable it, and that essentially, by default, turns off, syncing, turns on scheduling, and allows you to join nodes directly into your vClusters. So while it is not possible to convert a shared node traditional vCluster into one with private nodes today, that's not something you can do. You can, however, spin up a new vCluster within seconds, just as you would spin up any other vCluster. So it's really easy to, if you already have like 20 vClusters running, spin up number 21 and experiment with private nodes. Of course, there's a feature flag that needs to be enabled for you to have access to this feature. You can reach out to our team if you're interested in testing private nodes.
For developers or platform engineers who want to try this today, where should they get started?
I would just suggest to get started with the first vCluster on, your local host laptop, right? Like literally just spin up Docker desktop, Minikube, kind, whatever is your favorite, localhost cluster, and then launch a vCluster, play around with it. Even if you want to use private nodes, one of the interesting things, and my CTO does this all the time in his demos, is to create a localhost, Docker desktop cluster, launch a vCluster on top, and then spin an EC2 instance up in AWS and join that EC2 VM into the localhost cluster as a private node. That's really fascinating because your control plane runs locally, but your actual workloads, if you run something on this vCluster that has the private node attached, if you run something on this vCluster, it'll actually run in AWS in the end. It doesn't run in EKS, but it runs on top of an EC2 node that is attached to your private node vCluster. So there's some really exciting things you can do there. And yeah, I would just encourage everybody to get started and play around with things. And if you want to test any of these, features that may be behind, the enterprise paywall effectively, you can go to vcluster.cloud and spin up an enterprise trial, which will give you access to all the enterprise features for a period of 2 weeks. So that's a great way to explore anything we're shipping that's completely new if you want to just kind of play around with it.
And before we wrap this up, can you talk about what is your long-term vision when it comes to vCluster and Kubernetes multi-tenancy?
I think for us, it's really, covering the entire spectrum of tenancy, all the way from soft multi-tenancy as close and as lightweight as a namespace, all the way to, as heavyweight, the most resilient HA type Kubernetes cluster you can imagine that runs in single-tenant mode. We want to cover the entire spectrum. And vCluster is the foundation for all of this. But there's adjacent technologies you need around this. For example, vNode to, get you this node level isolation if you are more on the hard side of multi-tenancy, but you still want to run multi-tenant clusters with shared nodes. vNode is a great addition that complements vCluster. And we think there will be other, adjacent things around vCluster, but vCluster is really the central component. So that's why we decided the company just needs to be named after this really essential central piece.
It's quite clear after listening to Lukas that private nodes aren't just another feature. They are opening the door for new kinds of workloads and stronger guarantees around isolation in Kubernetes. Lukas, thank you so much, not only for developing these technologies, but actually for walking us through this launch. Thank you for your time today, and I look forward to our next discussion.
Awesome. Thanks for your time.
Thank you, Lukas. For those watching, if your team is tackling problems in Kubernetes, multi-tenancy, or exploring how to run sensitive workloads with more confidence, we'd love to hear from you. And also, don't forget to subscribe, like, and stay tuned for more conversations.